Hi guys, welcome back to part 3 of the one factor ANOVA demonstration here. So here we're going to finally get to working through the values on this problem. We discussed the hypothesis tests, some of the assumptions of one-way ANOVA. We introduced some of the formulas, and now we're going to actually apply them. So if you recall, we talked about total sum of squares, treatment sum of squares, and error sum of squares. We're going to actually get those values now. Before we do, there's a couple things that will be super useful for us. So we're going to get a couple things out of the way. Remember, K is the number of groups. Y bar dot dot is the average of all the observations. Y bar 1 dot is the average of the observations from group 1, which is for us P. Y bar 2 dot is the average of group 2, and Y bar 3 dot from group 3. I need to adjust these, obviously, so let me do that. Okay, great. Now that we have these out of the way, we can more simply calculate our sum of squares. Okay, let's get a little space here. So I'm going to do sum of squares total. So here, I remember have to take each value and subtract the grand mean from it. I'm going to lock the grand mean and I then square it. So that is that needs to be repeated for every single observation. So for example, you see here a 0 and here a 0. That's because that was 37 minus 37 squared. That was 37 minus 37 squared. For example, here it's 33 minus 37. That's 4, negative 4 squared, 16. So we know we're doing the right thing. But remember, the formula called on us to sum this. Sum all these elements. And so there's our total sum of squares. Perfect. So that would be 336. We're filling out the ANOVA table, right? Next, treatment sum of squares. Now, I made a mistake in that very first video, and you should have seen a little annotation pop up correcting the formula. So let me just remind you what the formula here was. Well, when we do it, we're going to notice. So here, I'm going to take each y bar, so let me use parentheses, and subtract y bar dot dot from it, lock that, and then square this. But what I forgot to mention in that, well, what I forgot to write in that first video is then we multiply this by the sample size. So here we could use the count function. And just simply count how many observations there are in each sample. So that would be the first element. And then we'll just repeat that. And we'll just need to adjust this a bit. My mouse is acting up a bit. Okay. Now we sum this. And that is sum of squares from treatment. So once again, what I forgot to mention in the previous in part 1 was the formula for this guy. I had, let me remind you what I had. I had 1 to k. You should see an annotation there, but in case you missed that, I had y bar I dot, which is the mean from group I, minus y bar dot dot, which is the grand mean, squared. I think I just left it at this, but actually you need to multiply this, each of these terms, by the sample size of the respective group in question, which is exactly what we did here, and here, and here. and then sum them all. Okay? And then finally, let's get sum of squares from error. So SSE, actually, let's put this in its place. Sorry, we put 336 in the wrong place, right? That was total sum of squares. And this one is going to be treatment sum of squares. So, okay, right? Treatment sum of squares, right? Total sum of squares, right? Okay, and now we're going to get this guy. Actually, we know what this guy is going to be because we know the relationship is this guy equals these two, the sum of these two, right? So actually we can use that knowledge and not have to do a lot of work for this. So we know that this must be this guy minus this guy. So if given sometimes professors will give you a partially filled ANOVA table with just enough information for you to be able to answer, to fill the rest of the table out and answer the hypothesis test, reject HO or fail to reject HO. So here we just used one kind of simpler way to get the sum of squared errors. Okay, fantastic. So now let's get the degrees of freedom. So we know that the treatment's degree of freedom is k minus 1. We know k is 3, so we know this must be 2. We know that the error sum of squares is n. What do I mean by n? N is the total number of observations in the study. So it's the sum of the sample sizes. So we had 6, 6, 6, and 6, right? Or if you like, you could use the count function. We had 18, right? And we know that the total sum of squares, degrees of freedom, is n minus 1. So that will be n minus k, sorry. That's 15. And this will be n minus 1, or the sum of these two. So that's 17, right? Okay, so we're filling out the ANOVA table. And finally, the mean squares. So this will be the sum of squares divided by its degrees of freedom. This guy will be mean square error, is the sum of squared of error divided by its degrees of freedom. And F will be the ratio of treatment mean square divided by mean square error. And so our F value is 36.71. In the final video, I'm going to show you how to make that final step, which is comparing F to a value from the F table, from the F distribution, and drawing your conclusion. So in the next video, I'm going to pull up an F table. We're going to get the value that we were discussing in the very first video, F upper critical value, and then compare that to F and make a conclusion. So be sure to watch the final part so that we can come to this conclusion, whether to reject HO or fail to reject HO.